All right, so lesson 3 is all about simplifying rational expressions with multiplication and division. I like to do this lesson after the addition and subtraction because it's so much easier. And I feel like if I do it first, that you'll like get a bad habit of thinking you can do it with adding and subtracting. So I always like to say that rational expressions are made for multiplying and dividing. Fractions are division. You know, the division symbol itself, I don't know if you've ever noticed this, the division symbol itself actually is a fraction with blank spots on the top and bottom. So when we have to divide or multiply with fractions, it's really, really easy, okay? All right, I'm going to factor 81 minus x squared. 9 minus x, 9 plus x. And I'll factor x squared plus 3x is x times x plus 3. Then I'll factor this is already factored. Then x squared minus 10x plus 9 is x minus 9 and x minus 1. Now remember that this division bar, called a vinculum, is a grouping symbol, so it's like there's parentheses there. Also remember that we can't cross out until we factor out. But now that we've factored, we can cross out anything on top with anything on bottom, even if they're across the multiplication sign. So I can reduce the x plus 3's to 1. I can also reduce the x minus 9 and 9 minus x. They are perfect opposite factors, so they reduce to a negative 1. So my final answer is negative 9 plus x over x times x minus 1. And we'll just leave it factored. We don't need to distribute or anything like that, and I actually prefer it if you don't. All right, now this is something we definitely can't do with adding and subtracting. Adding and subtracting, we got to get common denominators. Multiplying, we don't need common denominators. We just multiply top times top, bottom times bottom. All right, let's take a look at this one. Oh man, this one's going to be tough. We got to multiply everything on top and everything on bottom. So I got to do 5 times 3, that's 15. Times 7, that's like, what, 105? And then I got to do times 4, and then times 88. Is there an easier way? Let's just reduce first. The 4 and the 4 reduce to 1. The 5 and the 5 reduce to 1. The 3 and the 3 reduce to 1. The 7 and the 7 reduce to 1. And 11 goes into 88 8 times. I would argue that is even easier than typing that in a calculator. All right. So yeah, this actually used to be on a like SAT test a long time ago. I haven't really heard about them on there recently. You should do this stuff. And, you know, because it's time is an issue, people would spend too much time multiplying when they should just be crossing out. All right, let's take a look at the next one. This is already factored as much as it can be, but the bottom can become x minus 4, x plus 1. Remember that we need to know our pattern for the sum of two cubes. This is x plus 1, the cube root of x cubed, the cube root of 1. Then I square x, multiply the two together, and change the sign, and square the 1. That's the pattern. Let's review it again. When you see a perfect cubed plus or minus a perfect cube, you take the cube root of x cubed, that's just x. The cube root of 1 is 1. Then, to fill in the trinomial that comes after it, I just look at this part here that I generated from the cube roots. And I square the first term, and then these two get times together and switch the sign. That sign goes there, and then that sign's a switch. And then I square the last term. The first and last term are always positive. All right, x squared minus 25 is x minus 5, x plus 5. All right, and now the fun part. Cross out, cross out. When I cross out, I always think the little cross out is actually a 1. See, I'm really calling this 1 and 1. I think that's a good way to think about it. 1 and 1. So I'm left with x squared minus x plus 1 over x minus 4 times x plus 5. And again, we will leave that factored. Of course, we've seen problems like this before with our exponents. We want to make sure that we don't forget how to do that. This is a different kind of problem because there's no add or subtract in it. If there's no add or subtract in it, then we could say that it's technically already factored. So I can reduce the 5 and 10 to 1 and 2. X cubed and x cubed reduce out to 1. And the y and y to the 5th become y to the 4th. So I have 9 y to the 4th over, I think, just 4. Two times 2 on the bottom. The 5 and the 10 reduced to 1 and 2. And then this was a y and a y to the 5th reduced to y to the 4th on top. Okay, well, it's time for you to do A, B, C, and D. Okay, let's see how we did. 8 plus 2x. We can't forget the first rule of factoring is to look for a GCF. Okay? So we'll factor out a 2. Leaving me 4 plus x. And then x squared minus 9 is a difference of 2 squareds. X minus 3, x plus 3. And then two numbers that multiply to 12 and add to 7 are 4 and 3. So x plus 4 and x plus 3. Now we get to reduce. X minus 3 reduces with x minus 3. The x plus 4 and 4 plus x are not opposite factors. To be opposite factors, that have to be a minus here and here. They're just the same thing. I can change the order of addition. Doesn't affect the answer. So those just reduce to 1. X plus 3 and x plus 3 reduce as well. And all we're left with on top is 2 times 1 is 2. And on bottom, just an x plus 1. All right, on letter B, x squared plus 3x plus 9 actually doesn't factor. There's nothing that multiplies to 9 and adds to 3. We got 1 and 9, that adds to 10. 3 and 3 adds to 6. So we'll just leave that alone. And think of that as like one big factor, if you will. Now we get to do our difference of 2 cubes. We saw our sum of 2 cubes earlier. The difference of 2 cubes is very similar. The cube root of x cubed is x. The cube root of 27 is 3. Then we square x, making it x squared. Multiply these two together and change the sign. And then square that. And you'll note that, just for fun, I made that and that the same. So you can see that entire thing cancels out. 1 minus x and x minus 1. Those are the opposite factors we were talking about because they had the minus and they're in different order. So our answer is a negative 1 over x minus 3. All right, on letter C, we have x minus 6, x plus 6 over x minus 6, x plus 1. X cubed plus 1 is x plus 1 times, now remember, cube root, and then we look here, square the x, multiply the two together and change the sign, square the 1 over x plus 6. All right, x plus 6 is reduced. X plus 1 is reduced. X minus 6 is reduced. I've got nothing left on bottom, so I actually don't need to write a denominator since it's just a 1 in the denominator. And all we're left with is x squared minus x plus 1. All right, letter D. We have 14a cubed b cubed over 2a squared times 5b over 7a. I'm going to reduce the 14 and the 7 to just a 2. I'll then reduce the 2 with that 2. And a squared and a make a cubed, so I'm just going to take them all out. And I'll be left with a 5b to the 4th. Okay, we're going to talk about keep, change, flip. And one of the little pet peeves I have as a math teacher is I don't like keep, change, flip being called a trick because it's not a trick. I've actually had other math teachers tell me it's a trick. It's not a trick. It's the very definition of division. In mathematics, we define division as simply multiplying by the reciprocal. So the definition of division by value b is to multiply by the reciprocal of b. So to be technical in math, if we want to be like if you ever get the great fortune to take an abstract algebra class in college, which is super fun, you'll learn that there really are only two operations in our real number mathematics that we build everything up from, and possibly three if you call exponentiation. But multiply and divide are the same. Add and subtract are the same. Subtraction, we could do all our math without ever putting a subtraction sign. We just have to say adding a negative. So instead of 10 minus 5, I would say 10 plus negative 5, and I can do all the math I need. I also don't need the division operator because I can always just say multiply by 1 over the number. So I don't know what you do with that information, but I think it's worthwhile to think about. The division symbol really just means this. Okay? But we remember that rule with keep, change, flip. So let's use it. We're going to simplify the following. Assume the denominator never equals 0. Okay, that's just me, again, making it easy. We talked about that in the last lesson. Keep the first fraction the same. Change the division to multiplication. Flip the second fraction. We're changing division to multiplying by the reciprocal. Now we'll reduce. 4 and 8 can reduce to 2. I'm going to reduce this x down to a power of 1 and the y to a power of 2. So on top I have 9 times 2 is 18. Xy squared. And on bottom it looks like I still have a 5. All right, well, what about letter B? We have some rational expressions here. We'll keep the first fraction the same. And in fact, I'm going to go ahead and factor it as I go. Now I'm going to flip this, and this is going to go to the top now. I'll factor out an x. And this is going to go to the bottom. If you're not sure about factoring and flipping on the same time, be sure to just do one at a time. Flip or factor first, and then go do the other. Okay. 2 minus x, x minus 2, that's our negative 1. X plus 8's reduce, and we're ready to write down our answer. So on top, I got a negative 1 times x. On bottom, I have x plus 4 and x plus 2. Okay, so when you have a problem that mixes division and multiplication, we just need to be careful that we only flip what we're dividing by. So I will keep the first thing the same. I'll change the second thing to multiplying by the reciprocal. And then this is a times. So with times, we don't change anything. Now, I didn't do any factoring yet, so let's go ahead and make sure we've done that. Not a whole lot I can factor here, but it looks like we can factor out a 3x on the bottom. There we go. Oh, x squared plus 2. Okay, so the x squared plus 2s are going to go away. X and x goes away. So on top, we're left with just a 1. On bottom, we have an x minus 3, an x squared, and a 3. So I'll just kind of put it in a more conventional order. But you don't have to. The order of the multiplication doesn't matter. So it's time for you to do some practice problems. Got A through D. And that should round out, I believe, this lesson. All right, so on practice 3.2a, we can factor this as x minus 2 and x plus 1. This is x plus 4 and x minus 1. I can factor a 3 out of this. I think I may have told someone you couldn't factor that, and you can. I just didn't see it right. And then that's x minus 1 on bottom. Oh, you know what? I kept, changed, and didn't flip. Let me try that again. There we go. That's more like it. Reduce there, reduce there. So it's x minus 2 over 3 times x plus 4. All right, on the next one, I got 12a squared over b cubed times 5b to the 4th over 2a. That can reduce to 6. That'll take that down to b to the 1st, and that'll take that down to a to the 1st. So it should be 6ab. Oh, no, 30. Because 6 times 5 times a times b. All right, this one's kind of confusing, and I already messed up once. So I'm going to just take the time to keep, change, flip, and I'm not going to worry about any factoring. So I want to make sure I get that right first. And then change this as well. All right, now I'll factor. And that's how I think all those factor. And hopefully we have some things that match on top and bottom. Reduce, 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 reduce. I'm not seeing much else, though. So I think we have 2x times x plus 2. Don't. And x minus 1 times x minus 3 times x plus 1. Unless I messed up on my factoring, there's just a lot still left over. You can cross out this x plus 1 and that x plus 1, but you still have that one. You only get one pair to do. Okay, on this one here, we have x plus 7 over x squared plus 2. And this whole thing is over 1. Would be a nice way to think about that. And I can factor by grouping and factor out an x squared and factor out a plus 2. And when I factor out an x plus 3 out of each group, we're left with a nice matching x squared plus 2. So those go away, and I'm left with just x plus 7 times x plus 3. And again, we're not going to multiply that out because typically we prefer it like that in these situations. And it's less work, so we're not going to do it. Okay. On this one here, we'll, this numerator doesn't factor. It's the thing that multiplies to 4 and adds to 2. So maybe it'll cancel out with this here. We'll find out. Keep change that to 1 over x cubed plus 8. And x cubed plus 8 is x plus 2 times x squared minus 2x plus 4. And that's it. One of the things that I left here, and I know this is kind of in the middle of today, but I want us to come back to this. I want you to pretend you're me. So when I write a problem like for a test or a quiz or homework, I oftentimes start with what I want the result to be, and instead of um, writing out an answer and hoping it reduces something nice, I start with something nice and build out. For example, say I was like a sixth grade teacher and I wanted you to reduce a fraction to 3/5. Well, I might multiply the top and bottom by 2 and say reduce 6/10. So I start with the answer and work backwards. You can make some pretty tough problems there and, make your own practice, I guess. So let's come back and do that.